Hi everyone, so let's see how we would make code to express the binary search concept in Java. The code is basically going to search for a value in an array and return the location or the index number at which that value is placed. Now this code is specifically made for an array of different heights, and we're going to see if we can find the location of that height. And the heights are in inches instead of feet, just to make it easier for us to understand. And so we're going to have to make a method that takes in an array of heights and the height we're looking for. An example of an array of heights would look like this. This is an array of passenger heights, and it starts from 0 to 6, the index numbers of the array, and there's 7 passengers, and this is ordered. This is really important because the order is really important because binary search will not work if it's not ordered from least to greatest value. So it only works when it's ordered from least to greatest value. Okay. So we made the method header. And so binary search basically finds the middle index, so the value at the middle of the array, and compares it to the height we're looking for. Okay? So let's open up the sketch to help us visualize how this would work. So basically, in this array, binary search finds the middle. So the middle is at index 3 and the value is 68. So it takes the bottom value, the index of the bottom value, which is 0, the index of the top value, which is 6, adds them together, divides it by 2 to find the middle index number. So say we were looking for the location at which 63 is placed, the height 63. So we would compare it to the middle value. The middle value is 68. 68 is larger than 63. So we know everything after 68 will be larger than 63. So to narrow down our search, we're going to make our top that was equal to 6 equal to 2. And we do this by making top equal to the middle minus 1. And that helps us narrow down our search to 3 subarrays right here, 0 to 2. Now binary search does this again, and it does its coding again, and it finds the middle of what we narrowed down. So the middle of the bottom and the top. So it takes the top value, adds it to the bottom value, the index number. So the top is 2, index 2, and the bottom is index 0. So 2 plus 0 divided by 2, and it finds the index at what? The value at index 1. The value at index 1 is 62. We're trying to find what location 63 is at. So it looks at the middle value. The middle value of these 3 subarrays is 62. 62 is less than 63. So we know that everything before 62 and including 62 is less than the value we're looking for. So we can narrow down our search a little bit more, and we can kind of theoretically eliminate these 2 values because we know that our value does not belong to the bottom half of our array. So what we do now is, because it's less than the height we're looking for, we make the bottom equal to, so we can make the bottom equal to 63. So bottom equal to the index at 2. So we do this by we make the bottom equal to the middle plus 1. So to eliminate these 2 values, we make the bottom equal to the middle, which is 62, plus 1. So now we've narrowed it down to 1 value in the array. So the bottom is equal to the value at index 2, the top is equal to the value at index 2. And so now it finds the binary search, the method finds the middle value of this array. We only have 1 more value left in this array, and so the middle value is equivalent to whatever value we have left. So then it checks, is the middle value equal to the value we're looking for? Yes. So now we can return the location, which is the middle. We can return the location to the method. So let's get back to our program in Dr. Java to see how this would work. So we have a variable called middle to find the middle value in the middle of the array. We have a variable called top and bottom to find the middle. Top is equal to the length of the list minus 1. Bottom for now is equal to 0. So the index at bottom, the array at bottom, the array at 0 will be the smallest height value. And we have a variable called height location. And we assign this -1 because what if the height doesn't exist in the array? So we will have to return -1 if the height can't be found. And we have a Boolean variable called height found, and I'll explain why we have this later. So now let's initialize the middle. So the middle of the array, so the middle index is equal to top plus bottom divided by 2. Now, there can be 3 possibilities of where the height is. The height is either at the middle of the array. The height is either greater than the middle or less than the middle. So we have to make 3 if statements. So if the list at middle, whoopsie, list at middle equal to the height. So this height is from this parameter, height. Then we can just directly assign the middle value to the location of where our height is equals middle. Alright. Now, what if the list at the middle is greater than the height? So else if list at middle is greater than height. If that's the case, we're going to have to move the top So if that's the case, if the list at middle is greater than the height, so let's go back here. If list at middle is greater than the height, so if we're looking at, say, the height we're looking for is 63, if this value in the middle is greater than the height, we can move the top of the array all the way to 63. So all the way here, as you can see here, we can move the top all the way here because we know the middle and everything after the middle will be larger than the value we're looking for. And that helps us narrow it down. So let's go back. So its middle minus 1 will be equal to the new top. So top, the new top, to narrow it down, is middle minus 1 because we know all the values, including the middle, all the values after the middle, including the middle, is larger than the height. Now else, if the middle is greater than the height, it's less than the height, and this is our last possibility, so we just ended off with the else. We would have to change the bottom. So let's go back to the picture. Now the new middle is 62. 62 is less than 63, the height we're looking for. So we can kind of eliminate 62 and 57, everything before 62, including 62. We can eliminate that. To do that, we're going to have to change the value of the bottom. The value of the bottom is 0. Now we can change it to 2 because we don't need these two values anymore. We don't need them because they're less. We know that they're less than the height we're looking for. So we change the bottom to 2. So the bottom will be equal to the middle plus 1. And that narrows it down to our last array. So let's go back to the code. So bottom is equal to middle plus 1. Now, binary search does this several times. It continues to do this until the middle is equal to the height. So we're going to have to add in a loop. And a while statement is preferred. And we're going to have to add conditions to this loop. Let's fix this. Okay, so a while statement is preferred for this. So while. And now we have to give it a condition. So it can only continue to do this until we find the height. So until the middle is equal to the height. So when the value at the middle of the array is equal to the height, we could make height found equal to true. So the loop should stop once we found the height. So this loop can only continue to do its code when height is not found. So not height found. So when it's false. So it can only loop through the coding if it's false. Now, what if the height we're looking for doesn't exist in this array? If it doesn't, the while loop will keep on going and going until bottom will be greater than the top. So the bottom will eventually be greater than the top because bottom increases every time we go through a loop and the top decreases. So if the value of the height doesn't exist in this loop, doesn't exist in the array, the bottom will eventually be greater than the top. So we have to add in another condition and say this loop can only work if bottom is less than or equal to the top. Alright. So we have our search loop. So this loop searches through. So this basically means that this code will happen over and over again until the value in the middle is equal to the height we're looking for. And then now we can return, and once it is equal to the height we're looking for, that height of the location is at the middle. So we can return the height of the location. So return height of the location. Alright, so I've added in some comments to help us understand the if statements a little better, and I just organized them. Alright, so I also added in this if statement. So if the height of the location is equal to -1, and so that's when the height does not exist in the array, the program just outputs this height does not exist in the array. And so I've already compiled the program and fixed some of the errors. So this is supposed to be equals to the height, and I've added some semicolons. So I went to the interactions panel and I called our height search method, and I wanted to see if these values, so these heights, exist in the array. And so from the first to the sixth one, I used the heights that already exist, and every time I enter, they would give me, the program outputs the location. So 57 is at 0, height 62 is at 1, height 63 is at 2, and so on, and it goes all the way up to height 79, which is at the last location, array location. So this is how I would call it. I would use the class name and then dot the method name and then take in an array, so the passengers array. So I've used the passengers array and the height I'm looking for. So here I wanted to see if a person exists with the height of 90 inches in the height of passengers array. And clearly there is no person that is 90 inches in this array. So the program outputs this height does not exist in the array. And I've done this with negative 69 inches. Clearly nobody is negative 69 inches in this array, and so it outputted the same thing. And I've also done this with someone who is 5 inches, and nobody in this array is 5 inches tall. So it outputs this height does not exist in the array. And so that's how binary search works. And so the main code here would be this loop. And that, in essence, binary search just finds the middle number, the middle index of the array. It finds the value at the middle index of the array. It compares it to the value we're looking for. So here it compared it to the height we're looking for. And it sees if it's less than, greater than, or equal to the middle, than the height. And that's pretty much it. So thank you for watching. And that is how binary search works. Here's Manisha with the pros and cons of binary search.